Hello, welcome back to CE439. This is the second video of Chapter 7, Aggregation Production. In the last video, you learned about different types of crushers such as jaw, gyratory, and cone crushers. In this video, you will learn some other types of crushers, then learn how to calculate crushing production. First, let's continue with Section D, roll crushers, by watching the following short animation of roll crushers. With a roll crusher, as shown in the animation, rocks are crushed as they pass between two rotating rollers. Typical reduction ratio is 3:1. It means the product material is about 3 times smaller than the feed material. This picture shows a real roll crusher. This is a top-down view of a roll crusher. Roll crushers are sized by the dimensions of roller, including its diameter and the length. For example, a 30 by 18 machine has the rollers with a diameter of 30 inches and 18 inches long. Section E, impact crushers. Depending on the size and type, impact crushers can be primary, secondary,
or tertiary crushers. Let's watch the following clip about the principle of impact crushers.
From that video, you should notice that this type of crusher uses impact rather than pressure to crush material. The one that you saw earlier in the video is called vertical shaft impactor, since the shaft is in the vertical direction. There are other types of impact crushers, including horizontal shaft impactors and hammer mills, such as aka hammer mills. This figure illustrates a horizontal shaft impactor. The shaft of this machine is in the horizontal direction. The working principles of this are similar to vertical shaft impactors. Let's watch the following animation of horizontal shaft impactors.
This picture illustrates a hammer mill. It crushes rock using the impact made by many little hammers attached to a horizontal shaft. Let's watch the following animation on how hammer mills work.
The shaft typically needs to operate at a very high speed in order to create sufficient impact energy. This machine can achieve a reduction ratio up to 20 to 1. This table here is one example production capacity chart for impact crushers. It gives you the production capacity in tons per hour, given the size of feed material and in which crushing stage you use the machine for, such as primary crushing or secondary crushing. Crusher manufacturers also provide gradation charts. Vertical axis is the percent cumulative passing, ranging from 100% to 0. The bottom horizontal axis represents the screen sizes in millimeters. The top one shows the sizes in inches. Each red curve here shows the percent passing at different screens. Section F, mills, also known as grinders. This type of crusher reduces particle size
by tumbling, stirring, or vibrating the stone with a grinding material. The grinding material may be steel rods or balls, sand or ceramics. Mills are used to produce very fine particle sizes, such as cement. Let's watch the following video about milling.
Ball milling method. In this video, we are going to see about ball milling method. One machine that is heavily used for crushing and grinding task is the ball mill. This machine is described as a grinding device capable to crush and transform large hard materials into fine powder. A ball mill is a cylindrical machine generally used for mashing and crushing paints, ceramic materials, ores, and other hard materials. Feed material, dust collection, finished product, grinding ball. By rotating on a horizontal axis, the ball mill effectively turns hard materials into fine powder. The grinding materials are actually small balls which crush and grind the material that is inside the ball mill. Usually, stainless steel or ceramic balls are used as grinding materials. When the ball mill rotates, the balls crush and grind the material inside, creating in this way loose powder. The end result is crushed material that can be used for other purposes.
As noted earlier, we can feed the crusher directly from a dump truck or an excavator. However, using these two methods is making lots of issues to the crusher production, since it may be fed with too much material at a certain time, but does not receive enough material at other times.
Using a feeder to control the feeding rate would help minimize this issue. Crusher production will be increased if the stone feeds at a uniform rate. Using a feeder in advance of crusher can eliminate problems with surge feeding or underfeeding the crusher. Let's watch the following clip about how feeders are used.
The selection of feeder to use depends upon the size of the material to be fed.
There are various types of feeders. A popular type as shown in this picture is the use of a plate, pan, and sometime with grizzly feeder. It is set with a certain slope and vibrated to move material down. Another type of feeder is a feeder, which is shown in these pictures. Here how it works.
Today's mines and quarries often run automatically for longer hours and with fewer personnel, and they require equipment that can reliably handle material day in and day out. FL Smith has more than 135 years of experience in helping customers improve production, raise efficiency, and lower their operating costs. The newly redesigned apron feeders from FL Smith easily handle high-impact feeds consisting of heavy, coarse, and sharp materials from trucks, crushers, surge piles, bins, and hoppers. These heavy-duty feeders offer excellent protection against abrasive material with sharp profiles and hard edges, providing lower maintenance, higher availability, longer life, and reduced operational cost. FL Smith apron feeders feed material at an adjustable rate to compensate for irregular incoming material flow. Designed for easy maintenance, they are ideal for a number of mineral processing applications, such as metals mining or quarrying, at the surface or underground. They efficiently convey and meter material of different sizes and densities, from dry and abrasive to wet and sticky. Apron feeders can be installed horizontally or at an incline prior to any crushing or sizing, as they withstand the high-impact forces from large runoff mine material as it is tipped directly from mining trucks. Acting as an interface between mining trucks and the processing system, apron feeders provide steady, controlled feed for downstream processing, improving plant efficiency, increasing product output, and wear parts service life. FL Smith apron feeders are designed to provide easy operation, easy maintenance, and a long service life. FL Smith, we discover potential.
Belt feeder is a modified version of apron feeder. It is like the belt is what you see in the airport. Wobbler feeder is another common type of feeder. The wobbler feeder consists of a frame, elliptical bars, and chain drive system used to rotate the bars. The bars are elliptical in shape. The following clips shows how it works.
Belt conveyors are another basic tool in material handling industry. Belt conveyors consists of two powered pulleys with a continuous loop of belting material. Belt conveyors are the most economical powered conveyor and are typically used for conveying products over long distances, at high speeds, or for incline and decline applications. Section 4. Crusher production. Let's do an example here. A universal 4,250 jaw crusher with a closed setting of 3 inches will produce how many tons per hour in the following size ranges? Over 2.5 inches, between 2.5 inches and 1.5 inches, less than 1.5 inches. Given that the stone to be crushed has a unit weight of 110 pounds per cubic feet. To solve this problem, you need to determine the crusher capacity and the size gradation or distribution. Okay, let's calculate the total production of the crusher. The model is given as 4,250 model. The closed side setting is 3 inches, so we got the production capacity from 243 to 365 tons per hour. Let's use the average, 300 tons per hour. Next, you need to adjust the capacity, since the rock density is different from the reference 100 pounds per cubic feet. According to the problem, the unit weight of the material is 110, which is heavier than the reference. It means that your product capacity would be larger. So the unit weight adjustment is equal 110 divided by 100, or 1.1. So the adjusted capacity is the reference capacity 300 times the adjustment factor 1.1 you got 330 tons per hour. Now, you use this gradation chart to find the percent passing for different material size and the final output. Recall that the problem asks you to find the production for the following size: over 2.5 inches, between 2.5 inches and 1.5 inches, and less than 1.5 inches. So you need to look for the percent passing for those sizes. Given the closed side setting of 3 inches at the screen size of 2.5 inches, the percent passing is 64%. At 1.5 inches, it is 40%. Now, let's use this table to find the total production for each product size. Remember that the total output, as found earlier, is 330 tons per hour. In this table, the first column includes the screen sizes, which are infinity, a very large number, 2.5, and 1.5. In the second column, you need to find the percent passing. For infinity, it is 100% passing. At 2.5 inches, it is 64% as we found earlier, and 40% for 1.5 inches. Next, in the third column, we need to find the percent of material with size in a certain range. Between infinity and 2.5, we got 36% by subtracting the upper value 100 by the lower value 64. So 36% is the portion of the material with size greater than 2.5 inches. If you repeat this process, 64 subtracted by 40, you got 24% for material size between 2.5 and 1.5. Finally, 40% is the percent passing 1.5 inches, so it is the percent of material smaller than 1.5. If add the percent in this column, it must be equal 100. If it is different from 100, you need to check your calculation. In the fourth column, you put the total output of all sizes, 330. To calculate the total production for each size range, you multiply the percent in range in the third column by the total output of all size. For example, for material larger than 2.5, you got 36% multiplied by total production 330. Then you got 118.8 tons per hour. Repeat this for the range from 2.5 to 1.5. You got 24% times 330, or 79.2 tons per hour. For the range less than 1.5, it is 40% times 330. You got 132 tons per hour. The total of this column must be equal to the total output 330 tons per hour. If it is not equal, check your calculation. Section 5. Screen Calculation. As noted in the previous video, the objective about calculating required screen area has been removed from this course after a critical review of the course scope. You are not required for this section, but you are encouraged to read the text for your information. You are required to complete and submit the first 2 practice problems in the end of your note. The third problem has been removed. You are not required to complete this problem. This is the end of this video, which is the last video of the course. I wish everyone all the best. Goodbye.